Okay, hi folks. We're doing part B of this question. If you want to look at part A, it's the previous video. This is part 2, part B. And we've used suvat for part A. And now we're trying to find the mass of B, this mystery M, on this question 1 of the worksheet. So we did use suvat for part A, but if we're trying to find a mass, of course there's no M in suvat. No M in suvat, so we can't use it to find a mass. So what I've done is I've decided to look at forces and see what's going on, and I'm going to use our F equals ma equation for part B. So part B is going to be F equals ma is going to be key, partly because we know the acceleration, but partly because we're trying to find the mass. So what I've drawn onto my diagram is I've drawn all the forces. Now you're probably expecting some of these forces. So the weight of particle B, if it's got mass m, is m times g newtons. And the mass of particle A is 2, so we've got 2g newtons. So the weights are the main forces at play here. But we know the whole system moves. These weights don't balance. We know that A is accelerating downwards, that's down here. And we know B is going upwards. So what's enabling that to happen? Well, what's enabling that to happen is the tension in the string. So that's the force that is working on this system. It's the force pulling B upwards. And it's also slowing the acceleration of this 2g. That was not under tension, of course. Our g would just be constant. It would accelerate at 9.8 meters per second per second. But it's not. So t is holding it back. And these are the same value. The whole question is going on about how smooth this pulley is, how unstretchy the string is. It's a very smooth system. So these two tensions are identical. In this string, there's nothing there's no friction up here to make them different. The secret is to this then, is having a look at the two particles completely separately, because as a system we'd have to include the pulley, and it's not moving up or down. We don't really care about what's going on for the pulley. So if I put my hand over it, ignore particle B for a moment and just look at A. See what's going on for A. So this is all just a one-dimensional problem. It's got two forces on it and it's accelerating downwards. So we can just apply F equals ma to this problem. We can take our positive direction and let's see what that gives us. So for A, so if we consider them separately, for A, well, it's moving downwards. I'm going to put down as the positive direction. We've got 2g force pulling it down. And it's being resisted, not by friction, but by T. And that is producing, so that's our F, and we just need the mass times acceleration on this side. The mass is 2 kilograms there. And acceleration, well, the acceleration we work out is this. So this is my M, this is my A, and this is my F. For particle A, and I can simplify that a little bit. 2g minus t is, let's double that, let me have a think, 1.92 I think, and then t, I can rearrange for t, would be 2g 1.92. We can put that in the calculator because g is just 9.8, isn't it? Let's put this underneath. 9.8, so that is 19.6 minus 192. Put this out in my head, no. 401. 401 again. 7. 1, okay. 17.68, this is our T, so it's a force, so it is in newtons. Okay, so I've worked out T, it's not what I want to find M, but I think when we look at B, we might find what we're looking for, because B is the one that has mass M. So let's look at B, and completely ignore, so try and just cover it up with a piece of paper. Oh, I've got a piece of paper there we go. Covering up A, what's going on for B? It's moving upwards. So I can even take the direction as different. imagine that B is just going upwards, so I might use there, yep, upwards is plus. The force pulling upwards is the tension, it's being held back by its weight. So this time its upward movement means that we get T minus mg, which is its weight, that's the force, and that's going to be equal to the mass times the acceleration. So on this side, this deceptively simple equation gives us m times what is the acceleration? We don't have a stretchy string, so our acceleration is the same for both particles, 0.96 that we got in the first bit. M times 0.96. So this is our equation to find m. Now, what we do know is T, and T in both bits of the string. So we can see 17.68 minus mg, remember g is just a number, equals m minus 0.96. Let's see if we can rearrange this for m, add that mg onto that side. And then this is just as close as I can get without a calculator. And then finally I'm going to put in my g as I tend to do that at the end, but you can put it in earlier. It's always going to be 9 meters per second, and that's 17.68 divided by 9.8 0.96, whatever that is. It looks like it's going to be about 11. So my m is going to be about 1.7. Actually, they give us the answer, but double check that on a calculator if you like, that we get 1.6. Okay, so part B, a little bit more complicated. We need two equations, but the key is, where we've got a system like this, look at A and B, cover the other of them too complicated by trying to look at both at the same time. When they're going in different directions, totally consider them separately. So that's my big hint, is that for A and B, we look at them, part A, B, we look at them as if they're totally separate, even though they have stuff in common. And again, question. Part C, I'll just add it on because it's only a 1 mark moment, is how you have used the information that the string is inextensible. Extensible just means not stretchy. So what that means for our system is if the string was stretchy, what could happen? Have a think about that. For me, when I think about the, I imagine that A would certainly accelerate, but B might not accelerate upwards at the same rate. They might get further apart from each other, so it might be a delay before B pings back up. So I think these would be different. So the way we've used the inextensible string is by saying that it is the same for both, and the tension is the same for both, but essentially the main thing is the same for both particles, which we did use. We used the same acceleration for B as we used for A. Okay. All right, let me know if this is useful or any good to you, and I will see you soon.